And now for something completely different.
With momentum. All right, so welcome. We're learning about momentum right now. You're in the process of learning. Okay, so what is momentum? Is it like Spider-Man swinging and smashing into someone? Yes, it could be. Momentum of an object depends on its mass and its velocity. Okay, so the more mass you have, all right, the more momentum you have. The more velocity you have, the more momentum you have. If you are missing one of those two things, if you have no mass, you don't exist, so nobody cares. If you have no velocity, then you are at rest, and so you have no momentum. One common thing is to talk about the difference between inertia and momentum. Inertia is independent of an object's velocity. Inertia is just how fast, take that back. Inertia is just how much mass an object has. So inertia means the property of matter to resist a change in motion. So if you have a ton of mass, then it's hard to change what you're doing. And so and it has nothing to do with your velocity. All right, momentum is taking into account that, well, if you have a bunch of mass and you're moving fast, then it's hard to change what you're doing. So two different but similar concepts that are often paired together. So you have to know the difference between those two things. Yes, momentum is a vector quantity. And so momentum's direction is always the same as the velocity's direction. So P equals mv, you can see we have units there of kilogram meters per second. We don't have any fancy units like we do for force, we just have kilogram meters per second. So that's pretty fun. Okay, so which has a greater momentum? A car, this is boring, 1,100 kilograms traveling at 30 meters per second, or a bullet, right? You might imagine that a bullet traveling at 500 meters per second would have more momentum. It's harder to stop a bullet, right? Unless you're Neo from the Matrix. Contemporary reference, you're welcome. P equals mv for the car. 1,100 kilograms times 30 meters per second. We just do some math. Boom, 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 boom. Smash it into your calculator. There we go. There's the bullet. All right. And we keep going there. And look, it's way less, right? So that's fun, right? So imagining you have bulletproof glass, it stops a bullet, and then you have bulletproof glass, and a car hits it. I mean, which is, I mean, yeah. So yeah, I tried to come up quickly with a non-morbid example. Next, yeah, how do you feel about this brown background? This is this diarrhea color scheme. This is what's going on here. Okay, so moving on from momentum to a similar thing. This is actually kind of how Newton thought about his laws and stuff. All right, and forces. But so an impulse. All right, for all you Trekkie fans out there, impulse power, that kind of stuff. All right, so what is an impulse? An impulse is a force applied over a period of time. So you can change an object's momentum, right, by changing its velocity, right? Same object, change its velocity, its momentum changes, right? Well, that is really what an impulse is. An impulse really just is a change in velocity. So in your reference table, you see this line that we have here, J is equal to delta P is equal to, FT is equal to M delta V. These things all go together. And actually, the only thing that you have here, you don't have this last bit of M delta V. You have to know that, frustrating, but all these things go together. So in order to change an object's speed, you have to apply a force for a period of time. Okay, units for impulse. They're actually the same, right? They're the same as a momentum. They have to be because we had that last line where stuff was equal. So impulse is also a vector, exclamation point. I know you're super excited about it. That's why I put an exclamation point there. You're welcome again. Kilogram meters per second, Newton seconds, those are the same thing. So excellent. Okay, yep, whatever. That whole thing. All right. So if one object is acting on another object, the change in momentum is going to be the same for both of those objects, right? Because so again, a baseball bat and a baseball, they're hitting together. All right. So which one has the greater force applied to it, the baseball or the baseball bat? Remember Newton's laws. Every action equal and opposite reaction. So they experience the same force. Cool. if they experience the same force, are they in contact with each other for the same amount of time? Yeah, of course they are. The ball can't be touching the bat longer than the bat's touching the ball. So same force, same time, has to be the same impulse, which means the same change in momentum. Yay. Moving on. Ooh, an example problem. Get out your calculators, boys and girls. All right. Calculate the momentum of a 2 kilogram cart traveling north. See that north? Remember, back to quantity. Spoiler. At 3 meters per second. 2 kilograms, 3 meters per second. Write down your equation. Very exciting. Substitute in. 2 times 3, carry through the units, 6 kilogram meters per second. But you're wrong because you didn't include the north, you silly goose. All right, so there it is. What is the impulse needed to change a 2 kilogram cart's velocity to 8 meters per second north? So that's that same cart from before. So our initial momentum, or excuse me, our initial velocity was 3 meters per second from the previous one, right? And then we want our final velocity to be 8 meters per second. Now they're both north, so we can leave them both positive, and we want to know what that impulse is. Okay, so J is equal to delta P. But what is delta P equal to? Delta P is equal to the mass times a change in velocity, that m delta V from way back when, all right, like 3 slides ago. So 8 minus 3, let me just put in my calculator here, get out my fingers, it's 5, all right? And 5 times 2, I know that, it's 10, all right? But again, it's a vector quantity, so we really should have a direction on there, and we should have units of Newton seconds or kilogram meters per second. No big deal, either way. Okie dokie. Second to last question, I think. Don't worry, we're almost done. We're almost done, kids. A 6 kilogram cart traveling west at 10 meters per second experiences a 15 Newton force to the west for 20 seconds. What is its new velocity? It's a new, really weird. All right, so again, we write down our givens, right? This is going to help us determine what equation to use. All right, so what information do we have? We have a force and we have a time. Okay, so Ft, there it is. The delta is not in your reference table. It's not really a big deal. We're going to always consider, just like always, we start time at 0. So initial time is 0, so you just, whatever, 20 seconds. All right. You like how I put that little decimal after 20? That means I definitely know it was 20 seconds. Sig fig's fun. Just kidding. Don't worry about them. All right. So our mass is 600 and we have a change in speed, but we don't know what our final speed is. So we are looking for that. Notice that if I were to divide this Ft, all right, by T and move it over to the other side, it would be F is equal to M delta V over T. And delta V over T is an A for acceleration, so that's F equals ma. So you could do this in a couple of different ways. You could, if you wanted to, use linear motion to determine the acceleration and then substitute in that acceleration to F equals ma to figure out the force, and then substitute that in for F and multiply that force times your time, and then get your impulse. I'm sure you've followed that totally, and you know exactly what I'm talking about, but let's do it this way. Negative 15 newtons is the force that we have, just substituting in the stuff that we have over here. All right, and we have an initial velocity. I didn't put that in. I don't know why. Leave me alone. Okay, so then we put it in. We've done a little math. You're going to add that 10 over to the other side right now. This unit right here, this momentum unit, you have to be super careful with directions and super careful with the directions when you're doing your math. If you're not, you're going to get a lot of questions wrong that are really actually pretty easy because it's, you're multiplying two numbers and subtracting them. Should be easy. But if you screw up directions or you don't carry through a negative sign, right, it ends up being incorrect. Okay. Yeah. See, like it right here, this is really negative times a negative, right? This negative times negative 10 meters per second. So it means I need to actually subtract that to the other side because it's a positive. If I had added it to the other side because I didn't pay attention to signs, I would have gotten the wrong answer. Ooh, that would have been sad. All right, and so we're calling west negative. We didn't say that at the start, but we were. Everybody knows it. We all knew it. We knew it. All right, last question. Or is it? Is it? I don't know. You don't know. Who knows? Nobody knows. All right, a 40 kilogram girl traveling east at 15 meters per second is brought to a halt. That's a fancy way of saying rest. A 40-kilogram girl. I don't know why I did that. I take it back. I wish I could have a redo, but I have a strict rule of one take. This is one take, so you're gonna have to live with it. I'm sorry. What is the force that stopped here? Okay, I'm just waiting for. Okay, there it is. 40 kilogram, 50 meters per second. These are the informations plurals that we were given in the question, and we can just imagine that because we're talking about impulse and momentum that we're going to be using that equation. Cool. If we didn't know that, right, we look over here and we say, I'm giving an initial velocity, I'm giving a final velocity, I'm giving a time. What am I looking for? I'm looking for a force. I know that F equals ma, so I could find an acceleration, multiply it by the mass, and get that. That would work. That would work. And a lot of you are going to end up doing that because you're going to be like, momentum is boring and I love forces. Or maybe not. Who knows? So this is the part of this equation we want to use. We don't care about the impulse, the J part. We just care about the FT and the delta P part. You're going to have to know that delta P is equal to m delta V. You're going to have to know that. That top line there in red is the only thing that appears in your reference table. You're going to have to know that delta P is equal to m delta V. Sorry. So substituting in at this point, it's just algebra, putting all your stuff where it goes, paying attention to negative signs, and you get negative 3,000 newtons. In this case, you would have gotten the correct answer, even if you screwed up signs somehow, because you have that nice 0 in there, but you would have gotten the wrong direction. So you might not have gotten negative, so you might have had the wrong answer if it asked for direction, if it cared about that. Okie dokie. All right, that's it. Just for fun, here's some more momentum. Here's Spider-Man swinging around and getting hit by stuff, and yeah, it's called engagement. You're being engaged with superheroes. All right. Bye, everybody.
Oh God.